Let's start with the lecture. I can see around 42 students in the class. So, a very good morning to everyone. I am Dr. V.N. Mathur, Professor and Head of the Department in Mechanical and Automation Engineering at Maharaja Agrasen Institute of Technology. And I hope this is your first class in fourth semester. So
Yes,
I'll be teaching you this course called ETME 210 IC engine and gas turbine. There are 2 online lectures and 1 lecture in the campus. So Monday and Tuesday are online lectures, and Wednesday and Thursday you will meet me in the campus. So you might be comfortable with attending lectures on MS Teams. In third semester, you attended various lectures on MS Teams. So if you have any question, you can raise your hand. And if not too many people are speaking, you can simply just unmute your mic and you can interrupt me wherever you want to. Okay, let me mute my phone also. So this course is about 2 things: IC engines and gas turbine. So if you can see this animation on right hand side top corner of this slide. I don't know whether my mouse is visible to you or not, but I am hovering over this animation. So this is an animation of internal combustion engine. The other animation is gas turbine. I don't know if it's visible or not. Yes, now it's visible. So in this entire course, we will be studying about the construction and the working of these 2 devices, as well as we'll revise some of the thermodynamic concept which you have studied in third semester thermal science course. So just to revise something which you studied in thermal science, you have studied about the first law of thermodynamics, the second law of thermodynamics, and then you made these kind of figures called heat engines. There's something called heat engine and there's something called reverse heat engine. So heat engine takes up some heat from a high temperature reservoir, QH, obtained from TH. TH is the temperature of the high temperature reservoir. And this engine, while working in a cyclic order, the working fluid in the engine operates in a cyclic manner. It converts some part of the supplied heat into work, W out, and reject the remaining part to a low temperature reservoir. So in this diagram, the temperature of the low temperature reservoir is TL. So this is what we studied while deriving Kelvin-Planck's formula for second law of thermodynamics and Clausius formula, Kelvin-Planck's statement and Clausius' statement of second law of thermodynamics. We also calculated the efficiency of such an heat engine. The efficiency or the thermal efficiency of heat engine is given by work output divided by heat input. So you can write here W out upon QH, and from first law of thermodynamics, W out is equal to difference between heat input and heat output. So QH minus QL. So the formula for efficiency becomes QH minus QL divided by QH. or 1 minus QL by QH. Then you also studied about the reversible heat engines and Carnot theorem and Carnot inequalities, which says that for a reversible heat engine, the ratio of heat transfer, heat interaction is equal to the temperature ratio of the temperatures. So that means QH by QL is equal to TH by TL. So if it is a reversible heat engine, then efficiency is equal to 1 minus TL upon TH. So that you studied in your thermal science. You also studied towards the end of that course these cycles called Otto cycle, diesel cycle and Duvel cycle. Here on right side of this slide, I have made this slide, this figure for the Otto cycle. There are 4 processes: isoentropic compression, then heat addition, then isoentropic expansion, and then heat rejections. So these are all theoretical concepts. So in this course, we'll see how does these concepts or these principles are applied for in actual devices. So before going into the construction of engines, let us first define what is heat engine. Heat engine is any device which would convert heat energy into work energy. So in actual practice, it's not temperature, it's not the heat which is transferred from a high temperature reservoir. In fact, there is combustion taking place in the engine. So it's the difference is the difference between theoretical and actual devices. In theoretical device, we assume that there's some device which is maintained at high temperature. If you are taking out heat from some source, then it cannot be maintained at a constant temperature. The temperature will go up, go down. In actual case, the source is not some reservoir which is maintained at high temperature, but the source of heat in engine is combustion taking place from fuels. So a heat engine which can convert the chemical energy of the fuel to the work. So that device is called heat engine. So if we divide the available heat engines, it can be classified into 2 different categories. One is the internal combustion engine and the other is the external combustion engine. Internal combustion engine is abbreviated as IC engines and external combustion engine are EC engines. So IC engines are those engines where the combustion is taking place inside the working chamber. And external combustion engine are those devices where combustion takes place at a separate place and the conversion from heat to work takes place in a separate place. This is the meaning of internal and external combustion engines. Now both of these types are classified into reciprocating engines and rotary engines. EC engine can also be divided into reciprocating type and rotary engines. And reciprocating IC engines can be spark ignition engine and compression ignition engine. So the ignition of the engine takes place because of the spark. It's called SI engine. Petrol engine, CNG engines, those are spark ignited engine, while diesel engine is a compression ignition engine. So we are going to study about these things. Rotary engines are open cycle gas turbine and Wankel engine, not part of our syllabus. Reciprocating external combustion engines are almost outdated nowadays. They are steam engine, they were used long back for driving locomotives, and even there were steam engine cars. Nowadays, we do not use them except in some specific places. Stirring engines are also reciprocating external combustion engine. And rotary external combustion engine are the turbines. It can be a closed cycle gas turbine or a steam turbine. They are used in power plant for production of electricity, and gas turbines are used as aeroplane engines. So this is a broad classification of heat engine. We are not going to study all of them. We'll be studying about SI and CI engine, and we'll be studying about closed cycle gas turbine or open cycle gas turbine plants. So I have already shown you an animation of engine and a turbine. So we, in this entire course, will be studying about the construction and working and the thermodynamic principles applied for working of these two devices. This, I hope you know from where to get the syllabus of the courses. It's from the website. This is the entire syllabus, as or other syllabus has 4 units. Now the first 3 units are from internal combustion engine, IC engine, and the 4th unit of the syllabus is on gas turbine. I have just transferred the content unit wise in this slide. So this is your first unit, with the second unit, third unit, and fourth unit on gas turbine. So every unit has 2 parts. So unit 1 is about basic engine component, classification of engines, working principles, comparison of 2-stroke and 4-stroke engines, ideal and actual cycles, their analysis, and valve timing diagram. This you will also going to do in lab. We have a lab of IC engine gas turbine. So one of the experiment is to find out or to draw valve timing diagram of the engine. Then the second part of first unit is on fuels. So chemical structure of the fuel, properties of SI and CI engine fuels, fuel rating, something called octane number of the fuel and cetane number of the fuel. Then a second unit is on carburation and combustion. So again, first part is about air fuel mixture requirement and carburetor. Now there is a numerical portion, calculation of air fuel ratio. So we'll be solving few numericals to find out how to design venturi of the carburetor or the fuel injection for a given air fuel ratio. Then construction of the carburetor and fuel injection system, fuel pump, injection pump, working principle of governor, nozzles and fuel injectors, injection in SI and CI engines. And this one is a very interesting part, the second part of the second unit. So how does the combustion take place inside the engine cylinder? So we'll study about the normal combustion and the abnormal combustion in SI and CI engines. What are the different stages of the combustion and what is detonation and knocking in the engines. Then again, third unit is on performance parameter for IC engine. So lot of this we'll be doing in our lab classes. So we'll, in the class, theory class, we'll write down the formula for engine power and various efficiencies. We'll draw performance characteristics curve and what are the variables affecting performance characteristics and method of improving engine performance, and how to calculate heat balance sheet of an engine. So this is again numerical portion. And in IC engine lab, we have diesel engine and a petrol engine on which we can perform these tests to calculate the power of the engine and efficiencies of the engine. We will draw some performance characteristics in the lab, and we'll also do an experiment on making a heat balance, like balance sheet, how much heat is supplied and what proportion of heat is used for conversion to work and what proportion goes in exhaust and what proportion is lost or used by the cooling fluid. So we'll draw a balance sheet of heat, so numericals as well as practicals in the lab. Then this second part is again a very interesting one. It's what are the developments which are taking place nowadays in modern automotive engines. So there are some changes in the fuel injection system. So what are the methods in SI and CI engine for fuel injection system? Common rail direct injection system, gasoline. Give me a moment, please. Okay, are you all there? Hello. Can anybody confirm? Am I audible?
Yes, sir.
Okay. So I was talking about what are the what are the changes in modern automotive engines. So most of these things will read from the available literatures of engines. So you won't find these topics in books because they are new, or the development in the engines which are being done by various R&D sectors of engine or automotive manufacturer companies. So we'll study about the direct injection system, variable valve technology used by different automotive manufacturers, and a brief review of design changes to achieve high efficiency. And as I said, last unit is on gas turbine. So introduction of gas turbine, I hope you remember Brayton cycle, which was one of the part of gas power cycle, the last unit in third semester. So we'll revise that Brayton cycle, and we'll see what are the difference between ideal and actual cycle, what is the effect of intercooling, reheating and regeneration, and what is combined cycle and cogeneration. Then we'll discuss about gas turbine cycles for aircraft propulsion. What is the criteria of performance, intake and propelling nozzles efficiencies, simple turbojet cycles, turboprop engines, what are thrust augmentation, gas turbine combustion system, combustion chamber design, and gas turbine emissions. So this is, in a nutshell, the entire syllabus of the course. It's a very interesting course. If you love mechanical engineering, then it's the most interesting part of mechanical engineering, because it includes a lot of concept from other subjects of the engineering. So once you start analyzing or designing engine, then you should have knowledge about fluid mechanics. You should have knowledge about what to call strength of material, which you have studied in third semester. Then heat transfer, which you will study in your next semester, and various other basic mechanical engineering subjects are used in this subject. So this course is a part of applied thermal engineering. So there is something called basic thermal engineering, which includes studying of the laws of thermodynamics, the cycles, and this is like how do you apply those laws in actual components. So this is few of the components of mechanical engineering. The other component is a refrigerator or the reverse seat engine. So that you will be studying in your 6th semester course, or probably 7th semester, I don't remember. Mechanical and automation engineering students read it in 6th semester, but for your syllabus probably it's in 7th semester. So all this is based on what you have studied in your 3rd semester thermal science. We'll be revising those topics which are essential, and then we'll go forward with this present course. Yes, about the books which have been prescribed in the syllabus is one by V. Ganeshan. Is a professor, probably now retired professor from IIT Madras, IIT Chennai. So he has written a very good book on IC engine. So this is the 3rd edition of the book. Nowadays 4th edition is also available. Not very expensive, might be 300-400 rupees. And there is another very good book by John B. Haywood. This is also mentioned in the syllabus of IP University. So I have got this 1st edition. This was around 700 rupees. They have also got a 2nd edition recently, and it's very expensive. It's I think more than 10,000 rupees on Amazon. It's not available in India, but there is an Indian edition which is around 300 or 400 rupees. So few copies of this book is available in the library, and you might get IC Engine by Ganeshan from the book bank also. You should have one book to study. So this is about the first 3 units of the course. As I said, the course is on IC engine and gas turbine. So the second part, the 4th unit, is gas turbine. So you'll have to refer another book for gas turbine. So for this 4th unit, the prescribed book is by Cohen and Rogers. Few copies available in our library. So this is about the introduction of the course. I have already talked about the classification of engine. I have talked about the syllabus of IC engine, which has two parts, and have mentioned about the books which you will require. Now the course, as I said, there are 2 online lectures per week on MS Teams, and I'll be conducting quiz during online lectures. And after the online lecture, I'll give you few questions to answer. And there will be offline quiz and tests. So whenever you come to meet me on Wednesday and Thursday, I'll be giving you quiz and I'll ask you questions. In all, you can expect around 6 quizzes and 2 class tests apart from the midterm examination. And I expect from you that you will remain regular and attentive. See, in online class, it's essential to be attentive also. And I'll check your attentiveness by asking questions between the lecture and after the lecture. And I also expect you to be honest in submitting all your assignment and quizzes. Okay, any doubts so far? I hope you can unmute your mic and speak whenever you wish to. But if too many people are speaking, then please raise your hand for your chance. Okay. So let's go to IC engine portion of the syllabus. Have you ever opened the bonnet of the car to look at the engine which sits inside the car or bike? The basic working principle of engine, whether it's a car engine or a bike engine, is same. So if you open, I've got a Wagoner. So if I have got a photograph of this engine. If I open the bonnet, it looks something like this. So this middle portion, I hope my mouse cursor is visible to you. This is the engine of the car. If you take this engine out, it's look like something like this. This entire device, it sits on rails by brackets in this bonnet. Now, you can see 4 pipes type of thing. There are 4 exhaust pipes on the left side, and on the right side there is an intake manifold, single manifold, and on the right side there are 4 pipes. So it's a 4-cylinder engine. So there are 4 different cylinders. So what happens is there's a piston inside the cylinder, and which reciprocates inside this cylinder. So there are 4 such kind of devices. I'll show you an animation. So this piston reciprocates up and down. When it comes down, it just pushes this crankshaft, which rotates, and this rotational power or rotational energy is then transmitted to our wheel by way of transmission system, which consists of clutches and gearbox and propeller shaft and drivetrain, etc. So I'll show you a photograph of one of the actual cylinder piston in cylinder arrangement. You can see this piston inside a cylinder, and on top there are 2 valves. It's a cut section of the engine, and you can see grooves inside the piston. These are grooves for piston rings, and on the bottom side, the horizontal one is the crankshaft. So just let us see what are the basic component of this piston cylinder arrangement. There is a cylinder block which is made up of the cast iron, within which reciprocates the piston, and the bottom portion of the block is used to as an oil reservoir. The cylinder block has water jackets in which water flows or oil flows for cooling of the engine, and the bottom portion is called crankcase. Now within this cylinder there is a piston which when moves inside the cylinder it varies the volume of the cylinder, so it's a varying volume cylinder. Now piston has piston rings. It's not visible in this figure, but I showed you in the previous figure there are piston rings, and the space between this piston and the top wall of the cylinder is called combustion chamber, where actual combustion of the fuel takes place. Now there are inlet manifold. You can see top left side pipe where air is coming and then fuel is entering. So this pipeline or this passage is called inlet manifold. And on the right side, you can see this pipe which takes away the exhaust gases or the product of combustion. This is exhaust manifold. And the passage can be open or closed by way of valves, which are inlet valves and exhaust valves. And between these two valves, at the top central, there can be a spark plug or an injector. So if it's a spark ignited engine, there would be a spark plug. If it's a compression ignited engine, CI engine, then there would be an injector. Now the piston is connected with the crankshaft or the crank by way of connecting rod, and by crank to the crankshaft, and there are other parts which are not shown in this figure like camshaft, cams, flywheels, etc.
Sir,
Anji,
sir, what is piston rings? Can you please tell me again?
What are piston rings? See, if you see on the top in this right side figure, there is a piston inside the cylinder and there are grooves. Piston rings have not been shown here, but within these grooves there are rings. You can see the bottommost groove to be slightly thicker, and then there are three grooves above this thicker groove which are thinner in dimensions. So the purpose of the piston ring is it does not allow the entire piston surface to rub against the cylinder surface. So only the rings are in contact with the cylinder, and also there is a oil film. So the surface to surface contact is avoided. So after some time, when the ring gets torn away, you can replace the ring. Yes, somebody is speaking.
Sir, basically the function of piston rings is to prevent the wear and tear of cylinder.
Wear and tear of the piston. There are two functions. Yes. One is to prevent the wear and tear of the piston, and the second function is it avoid leakage of gases from the top chamber to the bottom chamber. You can see this piston divide this entire space in two parts. The top portion is the combustion chamber where the combustion takes place. The pressure increases. Now, this high pressure gases may leak past the piston and come towards the bottom side. On the bottom side, there is cooling oil. It can contaminate those cooling oil. And if unburnt fuel air mixture is passing from the combustion chamber, it's leaking out, then it also contributing towards the pollution. It's not taking part in the combustion. So it's taking part in the pollution, it's reducing the efficiency of the engine, and if it's not doing burning, then the efficiency of the engine is reduced. So we do not want that this mixture, air fuel mixture, which is in the combustion chamber, should leak to the crankcase. So that's why there are piston rings which are provided. So you can say there are two different functions. One is to avoid leakage, and the second is to avoid contact between piston and cylinder. So rubbing is only between piston ring and the cylinder wall, so that after some number of cycles, say after 1 lakh kilometers, or your car manual has those time that after how many kilometers you should replace your piston rings. So after few thousand kilometers, you can replace your piston ring. You need not to replace the entire piston. Once the piston gets worn out, they can be replaced.
सर सर
बोलिए, आवाज आ रही है आपकी?
सर ये पिस्टन रिंग्स पूरे पिस्टन पे क्यों नहीं बनाई गई सर, आधे पे बनाई है?
हाँ, जहाँ जरूरत है वहीं बनाइए ना. ऊपर की जो 3 रिंग्स हैं,
यस सर,
it's sufficient. नीचे जरूरत नहीं पड़ती है. Actually, if we provide crevices are narrow spaces. If we provide lot of crevices, then the unburnt air fuel mixture may go into those crevices, and then again it can escape from the actual combustion process. We do not want any part of the air fuel mixture to escape from the combustion process. तो जितना ऊपर पॉसिबल हो उतना ऊपर ही रखा जाता है इसको. Any other question?
No, sir.
I think your class is till 11:40.
Yes, sir. The next class is from 11:45.
Okay. So just look at some of the nomenclature. In this figure, you can see a piston, then a connecting rod, and the bottom portion is crankshaft. So connecting rod in the first figure, the joint between connecting rod is at the top portion, and when the crankshaft is rotated by 180 degrees, this joint comes at the bottom portion. So in the left figure, the piston is at the topmost position, and in the right side figure, the piston is at the bottommost position. Now these two positions have a specific name. You can see here it's written TDC on the left side of the top left figure. So this is called top dead center. It's the top position of the piston, and when piston moves towards the bottommost position, it's called BDC. So if you see in the right side figure, the distance between TDC and BTC has been marked as L. This L is called stroke length of the piston, stroke of the piston. Now this entire volume is written as VC plus VS. VC is the clearance volume. So when piston is at top dead center, the volume of the cylinder is the clearance volume, VC. And when we add the stroke volume, that means the stroke length multiplied by pi by 4 into diameter square. So swept, VS stands for the swept volume. VC is the clearance volume. So when piston is at the bottom dead center position, the volume in the combustion chamber is summation of clearance volume and the swept volume. Now how do you calculate swept volume? If you know the diameter, if you see right side figure on the top, D is written. So this diameter of the cylinder, inner diameter of the cylinder, is also called bore. So if you know bore, then pi by 4 into D square is the cross-sectional area of the cylinder, multiplied by the stroke length is the swept volume. So swept volume plus clearance volume.
So could you please repeat that again, the last line? VS, how to calculate VS?
I'll just repeat. I said there are two dead center, top dead center and bottom dead center. The distance between these two dead center is stroke length. Then the inner diameter of the cylinder is called cylinder bore, represented by capital D in this figure. And you can calculate piston area if you if you can calculate swept volume, Vs is equal to pi by 4 d square into L. Piston area is pi by 4 d square. And so you can calculate the cubic capacity of this cylinder, which is Vs. And if there are k number of cylinders, then it's called KVS. Vc is the clearance volume. And the compression ratio is given by Vs plus Vc divided by Vc. It's the same R which we used in analysis of efficiency in Otto cycle and diesel cycle. So you derive this formula, neta is equal to 1 minus 1 by R raised to power gamma minus 1. So we'll correlate this thing with that Otto cycle PV diagram or TS diagram. For now, you should understand that the volume traveled by the piston is the swept volume, and when the piston is at top mode position is the clearance volume. The total volume in the cylinder is the summation of clearance volume and the swept volume. So when the piston is at top dead center, the volume inside the cylinder is clearance volume, and when the piston is at bottom dead center, the volume inside the cylinder is clearance volume plus swept volume. So what does compression ratio means? Is the ratio of volumes before compression and after compression. Before compression, the volume is Vc plus Vs, and after compression, the volume is Vc. So Vc plus Vs divided by Vc is the compression ratio of this cylinder or this engine. This is also called cubic capacity of the cylinder. And if you have, say, 4 cylinders, then the total cubic capacity becomes, Vs is the cubic capacity of the single cylinder. And if you have 4 such cylinders, then this cubic capacity of the engine is 4 times the cubic capacity of this or the swept volume of the single cylinder. You might have come across the cc of your bike or cc of your car, that your bike is 100 cc or 150 cc or 200 cc. Nowadays 700, 800, 1000 cc bikes are also available. The car engines, Maruti engine is 800 cc or 1000 cc, WagonR 1000 cc or 1200 cc, and there are truck engines of 2000, 4000 cc. So that cc
Hello, Pawan.
cubic capacity.
Sir, your internet was not working, so we could not listen like what you were teaching.
Okay. So I think when I explained this figure, BDC and TDC and swept volume, I think up to that time it was okay. Yes.
The last thing we heard was about the CC, like you were comparing like how nowadays like we have 750cc motorcycles and all that.
Okay. Okay, I can see some fluctuations in the net connection. So what we'll do is we'll stop here. So if you have any doubt in this slide, which I am just showing, so what I want to show here is I want to tell you what is the bore of the engine, what is the stroke of the engine, how do you calculate the swept volume of the engine using bore and stroke, one thing. Then second thing, what is the clearance volume of the engine, and how do you calculate the compression ratio of the engine. Compression ratio is ratio of volume before compression divided by volume after compression. So Vc plus Vs divided by Vc is the compression ratio. I think you should be able to calculate the compression ratio if the dimensions of engine are known to you. So if you know what is the piston diameter, if you know what is the stroke length, you should be able to calculate the compression ratio of a single cylinder. I'm stopping here. And if you
Sir.
have any doubt, yes.
सर आपने बताया सर कि लास्ट जो पिस्टन की रिंग होती है वो मोटी बनाई जाती है, वो क्यों बनाई जाती है सर?
To prevent leakage, oil leakage. We'll be studying in detail about each of these components later in the class. तो ये सब हमारे सिलेबस में है, ये सब हम डिटेल में पढ़ने वाले हैं.
सर
हाँ जी.
एनरोलमेंट नंबर नहीं मिला सर अभी कुछ बच्चों को, तो हम क्या करें सर फिर अब?
यूनिवर्सिटी से आया नहीं है, आपको कुछ नहीं करना है. वो डीन ऑफिस से ही आपका जैसे यूनिवर्सिटी से आ जाएगा तो वो आपको बता दिया जाएगा.
जी सर.
सर आई हैड अ डाउट सर. सर यहाँ
हाँ.
पे लेफ्ट साइड पे नॉमेनक्लेचर में इंजन कैपेसिटी में सीसी जो है उसके इक्वल्स टू में वीएस हो गया, स्वेप्ट वॉल्यूम है वो, बट के क्या है मतलब इसमें?
K is the number of cylinder. I said अगर सिंगल सिलेंडर इंजन है तो क्यूबिक कैपेसिटी इज स्वेप्ट वॉल्यूम ओनली. बट
Okay.
अगर मल्टी सिलेंडर इंजन है, एक ही इंजन में 2 सिलेंडर हैं, जैसे मैंने आपको भी बताया कि मारुति 800 जो कार आती थी उसमें 3 सिलेंडर होते थे.
Yes sir.
नैनो जो टाटा की कार है उसमें 2 सिलेंडर होते हैं. वैगन आर में 4 सिलेंडर होते हैं, जो भी मैंने आपको फिगर दिखाया था उसमें 4 एग्जॉस्ट पाइप दिख रहे थे. तो 4 सिलेंडर हैं तो एक सिलेंडर की क्यूबिक कैपेसिटी मल्टीप्लाई बाय 4 दैट इज इक्वल टू 996 सीसी, जो एक्चुअल में वैगन आर के इंजन की है. कुछ वैगन आर 1000 सीसी की भी आ रही है, 1200 सीसी की भी आ रही है. तो 1200 सीसी मतलब क्यूबिक कैपेसिटी ऑफ ईच सिलेंडर इज 300 cubic centimeter. So 300 cubic centimeter multiplied by 4 number of cylinder which give you 1200 cubic capacity. K is number of cylinder.
Okay sir. Thank you.
सर
हाँ जी.
चलिए स्लाइड शेयर कर दोगे आप सर?
हाँ मैं स्लाइड बिल्कुल शेयर करूंगा.
ओके सर, थैंक यू.
मैं अपनी स्लाइड हर लेक्चर के बाद शेयर करूंगा आपसे, लेकिन फिर भी मैं चाहूंगा कि आप जब मेरा लेक्चर सुनने बैठे हैं, मेरी बात सुनने बैठे हैं, तो अपने साथ कॉपी और पेन के बैठे और कुछ नोट करते चले जाएं, क्योंकि आप जब हाथ से लिखेंगे तो आपको चीजें याद रहेगी और डाउट भी क्रिएट होएगा आपके दिमाग में. और तो डाउट क्रिएट होता है मेरे से पूछ लें. केवल सुनने में अच्छा लगता है कि सब चीज समझ में आ गई है, लेकिन वो आप फिर भूल जाओगे थोड़े दिन में. तो अगर आप अपने हाथ से लिखोगे तो वो आपको याद रहेगी, और अगर याद नहीं भी रही तो जब आप अपने हाथ से लिखी हुई चीज को रिवाइज करोगे तो आपको याद आ जाएगी. इसलिए जब भी आप ऑनलाइन लेक्चर में बैठें तो अपने हाथ में पेन और कॉपी या पेपर जरूर लेके बैठें. Okay, that's all from my side today. We'll meet again tomorrow. You can I've downloaded the attendance, so now you can leave if you wish.
Okay, sir. Thank you.
Thank you.
Thank you sir.